Imagine this, you've just finished developing a new feature for your application, tested everything on your local machine, and it works flawlessly. Excited, you push your code to the server only to find out that it doesn't work there. This is the famous "it works on my machine" syndrome, a common circumstance that developers face. It comes from differences in environment configurations, leading to hours, if not days, of troubleshooting and frustration. But what if there was a way to ensure your application runs smoothly regardless of the environment? Enter Docker containers. Docker provides a consistent environment for your PostgreSQL database, ensuring that it works everywhere. Hello and welcome. Today we are diving into the powerful combination of PostgreSQL and Docker, a dynamic duo that can significantly streamline your development process. In this tutorial, I'll guide you through the essentials, from installing Docker on your system and setting up a PostgreSQL container to managing your databases with intuitive tools like TablePlus and pgAdmin. I've designed this guide to be practical, straightforward, and easy to follow, ensuring you'll have a running PostgreSQL database in Docker by the end. Now, before we start configuring Docker for PostgreSQL, we need to have Docker installed in our system. I'll quickly walk you through the installation process on macOS, which I'll be using for our demo. For those of you on Windows or Linux, the process is just as straightforward, and I encourage you to follow the official Docker installation guide that fits your operating system. Head over to the Docker website and download the desktop application for macOS. Once the download is complete, open the DMG file and then drag the Docker icon into your applications folder. After installation, open your applications folder or use Spotlight Search to find the Docker app. Upon opening the app, you'll be prompted to accept the terms of service. Then Docker presents you with two configuration options. First is recommended settings, which streamline your setup process and only require your system password for initial setup. And the second one is advanced settings, offering you the ability to customize port mappings, socket settings, and other configurations for Docker's CLI tools. For most of us, sticking with the recommended settings will be the best way to get started quickly and efficiently. Since I've selected the recommended settings, I now need to enter my system password. This allows Docker to apply the necessary configurations, such as installing networking components and setting up virtual machine privileges. Now we are presented with the welcome screen, where we can choose if we want to create a new account, log in with an existing one, or continue without signing in. For the purpose of this demo, I'll proceed without signing in, as we don't need an account to explore the basics of Docker and set up our PostgreSQL container. However, there are several reasons why you might consider creating a Docker account or signing in with an existing one. First would be access to Docker Hub. A Docker account allows you to download and upload your own images to Docker Hub. This is needed for sharing your work with others or accessing images that other developers have created. Second is collaboration. If you're working on a project with a team, having a Docker account lets you collaborate more efficiently. You can share Docker images and Docker files with team members, ensuring everyone is working with the same environment. Third is advanced Docker desktop features, because some advanced features of Docker desktop, such as Docker Compose and Kubernetes integration, are enhanced by having an account, providing a more seamless experience when managing complex container setups. And finally, we have tracking and managing images. An account gives you the ability to track and manage your images through Docker Hub, offering an organized overview of your projects and their dependencies. If there is a specific feature or an advanced topic you are curious about, just drop a comment below. Moving forward, we are presented with a screen that is completely optional. This screen asks you to provide Docker with information about your role and what you plan to use Docker for. Filling it out can help Docker tailor its updates and communication to better suit your needs and interests. However, it's entirely up to you whether you choose to share this information. The choice to skip this screen won't impact your ability to use Docker for our PostgreSQL setup or any other project. At last, we have Docker Desktop opened and running. As you can see here on the left side of the app, there are three important sections we will be covering in this video: containers, images, and volumes. Containers are essentially running instances of Docker images. They encapsulate the application environment, ensuring that your PostgreSQL database runs consistently across different development, testing, and production environments. Think of them as lightweight, portable environments where your application can live and run. Images are blueprints for containers. We'll be using the PostgreSQL image, which is a pre-configured setup that the Docker can run as a container. This makes it incredibly easy to start a database without needing to manually install and configure PostgreSQL on your machine. Volumes are used for persisting data generated by and used by Docker containers. When we set up PostgreSQL in Docker, using volumes will ensure that your data remains intact across container restarts and updates, providing a durable and consistent storage solution. You'll shortly learn how to add the PostgreSQL image to your Docker setup and how to persist your data using volumes. Regardless of your operating system, once you've installed Docker, you'll want to verify its installation by opening your terminal or command prompt and running the command docker -- version to see the installed version of Docker on your system. Next, to pull the PostgreSQL image, type docker pull postgres. This command fetches the latest version of the PostgreSQL image from Docker Hub. However, if your project requires a specific version of PostgreSQL, you can easily specify that by adding version number after docker pull postgres, which in my case will download 13.3. All you need to do is replace 13.3 with the version number you need to fetch and you should be good to go. When we execute this command, you'll see the download progress for each layer of the Docker image. Once complete, the image is ready for use on our system. To confirm the successful pull of the image, we can type docker images. This command lists all Docker images on your system. Look for Postgres among them, along with the version you've chosen to download. We can also open up our Docker Desktop app and find it under Images. With the Docker image now available on our machine, we are ready to take the next step, running a PostgreSQL container. I'll walk you through each step on the screen, showing you exactly what commands to run and what results to expect. I'm about to run a command that will spin up our Postgres container, and I encourage you to pause the video after I explain it so you can try running it on your own. First, I'll type docker run and then -- name. Assigning a name to your container makes it easier to manage, especially if you're running multiple containers. You can start, stop, and inspect containers more easily by name rather than by container ID. Next, we'll add -e Postgres password, and we'll assign a random password, something like my secret password, and this will set up a default PostgreSQL user's password to my secret password. Please make sure you replace this password with a secure one of your choosing. Then I'll add -d. Running the container in detach mode allows the container to run in the background. This means you can continue using the same terminal session for other commands without being attached to the output of the container, enhancing usability and workflow efficiency. Next is -p and then 5432. This maps the port 5432 inside the container to port 5432 on our host machine. By mapping the PostgreSQL default port inside the container to a port on the host, we enable direct access to the database from your local machine or other applications running on it. In this case, if the default PostgreSQL port 5432 is already in use on the host machine, the container will fail to start. If you are facing this problem, either free up the port or modify the port mapping to use a different one. Now, the important part that I see many people get confused. This tells Docker to create a volume named myPostgresData and mount it to data inside the container. This path is where Postgres stores its data by default. By using a volume, our databases or data we create within the container will be persisted in myPostgresData on our host system. With this, we can remove the container and create a new one pointing to the same volume, and your databases will still be there. Finally, Postgres latest specifies the PostgreSQL image version to use. You can replace latest with a specific version if needed. We've specified all the necessary options for our Docker command, including the container name, environment variables for security, port mappings, and volume for data persistence. By choosing Postgres latest, we also opted for the latest PostgreSQL version, ensuring we have the most up-to-date features and security fixes. With this, the command is ready for execution. As you can see, our container named myPostgresContainer is up and running, and the volume myPostgresData is also set up, ensuring our data persists outside the container's lifecycle. Now let's use the terminal to create our first database. We'll list all running containers to find our PostgreSQL containers ID. For that, I'm gonna use docker ps command. This command displays all active containers, allowing you to identify the Postgres container by its name or image. Once we located our container, we'll need the container ID for the next step. Copy that ID because we're about to use it to access the container's bash shell. Typing docker exec executes a new command in a running container. -it allows us to interact with the bash shell inside the container. Then we need to paste our container ID we copied before. And finally, we'll put bash that will automatically start shell inside the container. After entering the shell of our container, it's time to interact with Postgres directly. To access the PSQL command line interface as the default PostgreSQL user, run PSQL. This is the Postgres command line interface allowing us to execute SQL commands and manage databases. Then type -U Postgres. That specifies that we want to connect as Postgres user, which is the default super user in most Postgres setups. Now let's see what databases currently exist by listing them with the \l. This command shows all databases within our instance. To create a new database, I'll execute the following SQL command, and that's create database and then the name, which will be terminal_demo_database. And to confirm the database was created successfully, let's list the databases again with \l. As you can see, our new database called terminal demo database is now listed successfully. This confirms that we've managed to create a database inside our Docker managed Postgres environment. Now, for those who prefer graphical interface for database management, such as myself, let's explore how to set up TablePlus and pgAdmin that will help us interact with the PostgreSQL databases. For TablePlus, the first step is to download the application. I recommend visiting the official TablePlus website to ensure you're getting the legitimate software. TablePlus is available for macOS, Windows, Linux, and iOS. Once downloaded, the installation process is straightforward. For macOS users, open the downloaded DMG file and drag the TablePlus icon to your applications folder. Next, launch TablePlus and create a new connection to PostgreSQL. Choose the name for your connection. In the host field, enter localhost or IP address, both of which refer to your local machine where the Docker container is running. I'll set the port to 5432 since I used that one when running the Docker container. For user, I'm gonna type Postgres, which is the default super user for Postgres setups. Now we need to enter password we specified when creating a Docker container. For the demonstration, we used my secret password, but remember, in a production environment, you should use a strong and secure password. In the database field, you can type name if you want to connect directly to your database. We could, for example, enter the terminal demo database we created in the previous step. But for the sake of this demo, let's leave this field empty so I can show you how to select the database once we connect. Before you finalize the connection, take a moment to use the test connection feature. This step ensures that all your settings are correct and that TablePlus can communicate with your PostgreSQL database inside Docker. Once connected, click on the database icon in the top menu to select an existing database or create a new one. You'll notice that terminal demo database, which we created earlier, is already listed. Now let's create a new database directly from TablePlus. We'll name our database TablePlus_demo_database. I'll leave the encoding and collation options at their default settings. Upon clicking OK, the new database is created instantly. To connect to TablePlus demo database, simply select it from the list and click Open. Notice that our tables section is currently empty. Let's create a demo table. TablePlus makes this incredibly straightforward. Just click on the plus icon at the bottom left corner and select New Table. By default, TablePlus adds an ID column designated as the primary key, which is essential for uniquely identifying each record in the table. I'll name our table YouTube Video. In addition to the ID, I'll add a name column with the data type of varchar and set is nullable to no, ensuring every record must have a name. To save and create the table, hit Command+S on Apple devices or Ctrl+S on Windows and Linux. As you can see, the table now appears under the Tables section. Let's quickly add a dummy record in our YouTube video table. TablePlus offers an intuitive graphical interface, making it easy to add or modify databases, tables, and records. Honestly, as a software engineer, I find myself using this tool daily for its simplicity and efficiency. One aspect to be mindful of is TablePlus limitation in the free tier, where you're restricted to having only 2 databases or tables open at the same time. This might be sufficient for many users, especially those managing smaller projects or using TablePlus for learning purposes. However, for users who require more extensive access, such as software developers working on larger projects or database administrators needing to manage multiple databases, TablePlus offers a range of subscription plans. Now, for those of you who prefer a web-based database management tool, let's explore pgAdmin, which is another powerful option for interacting with our Postgres database in Docker. First, visit the official pgAdmin website and get the version compatible with your operating system. Follow the installation instructions provided on the site. By the way, pgAdmin is available for macOS, Windows, and Linux. Once it's open, you'll need to add a new server to connect to your Postgres. To do that, right-click on Servers in the left-hand browser tree and select Register and then Server. In the Create Server dialog, make sure you're in General tab and give your server a descriptive name. Moving on to the Connection tab. For the host name address, enter localhost or IP address pointing to your local machine where the Docker container is running. The port should be 5432, matching the port used when setting up a Docker container. Username, if you remember it from the previous step with TablePlus, is Postgres, and the password should be the one you specified for your Docker Postgres container. In my case, that's my secret password. Finally, click Save to finish setting up the server. To create a new database, navigate to your server, right-click on Databases and select Create Database. For name, I'll use something like pgAdmin_demo_database. Once it's saved, we can navigate to our database by going under Schemas, and then Public, and finally Tables. Here you can create new tables, insert records, or run queries. After setting up our database, let's proceed by creating a new table named YouTube Shorts, similar to the YouTube video table we created using TablePlus. One of the key benefits of using pgAdmin, whether as a desktop application or through its web interface, is its comprehensive set of tools for managing your PostgreSQL databases. Whether you're working from a laptop, desktop, or even accessing its web interface on a tablet, pgAdmin equips you with the tools you need to efficiently and effectively manage your PostgreSQL databases. These are the basics I wanted to cover on setting up PostgreSQL using Docker. If you're interested in more advanced topics on setting up and using Postgres with Docker, feel free to leave a comment down below. By the way, for those who are facing errors when configuring Docker or PostgreSQL, I invite you to visit my website. Right now, I'm working on an article that will cover most common problems with the setups and the steps you can take in solving them. Once it's ready, I'll make sure to leave a link in the video description for easy access. Before we sign off, please consider subscribing and liking the video if you find it helpful. That really helps the channel to grow. Thank you for watching, and I look forward to seeing you in the next tutorial.